Hey everybody, I got a special little video for you. I'm about to go into Cal Poly. One of the instructors, Trian, he sent me a picture of a bunch of students using these new mini mills that they just got. And I'm gonna go in and we're gonna catch up. I was in the area, so he's usually cool with us doing a little video, kind of keep people up to speed. If you see a video I did about, I think it was about 3 months ago, of them installing their 6 mini mills. So this will probably be a follow-up of that. This is a school that's in the Haas Technical Education Network, definitely leading the Central Coast and Valley. But a lot of schools are nipping at their heels. They're getting industry standard machines to help train these students to go out in industry or go out into the colleges and contribute right away. So let's go hang out with Trian and check this out. Hey, you got the Haas poster up there too.
Yes, I do. How are we doing, Scott?
I think we're on. So let's catch everybody up, shall we?
All right, so last time you guys joined us, we were just installing these 6 Haas mini mills. About 500 hours worth of work later, we now have our curriculum done and we're up and running. And you'll notice that the students actually just got done with CNC operation number 1 right here, where they learn about face milling, they learn about contouring on the CNC, and then chamfering on day 1. On day 2, we are going to flip it over and hold it in our chick vices in order to create all the different types of holes at the top of the part.
You've already had the freshman class come in, haven't you?
Correct. So actually,
like last week. It's only been a week or so, right?
Yeah. So we're in 2nd week of school now.
Yeah.
This is actually the first day of the 2nd week, and they were live on the machines this morning, machining parts.
That's the picture you sent me.
Correct.
Yeah, where every machine had like 2 or 3 students on it, right?
So we have the capacity for our lab is we have 24 students. 2 students are on the machine. Everybody makes their own parts. And then, while we have the 12 students working on the mills, 12 students are on the lathes individually making their own lathe parts. You can see everything we do has an engineering drawing, and they're making these parts within tolerance on these drawings.
All right, so you got the names on all the machines.
Correct.
Did you change the arrangement at all, or this is what we planned when we put them in?
This is what we plan when we put it in. We're engineers. We lay everything out on paper before we act. So, I mean, so we basically added all new curriculum.
Well,
so
you created this.
Yes, so you can see I wrote this manual. It's a 300-page lab manual. It takes the students through a 10-week course in machining. So if you look, these are the projects that we do in the course. You'll see right here's our first CNC project where they just learn how to run the mills.
Yeah.
Then in the second CNC project, they're actually learning about design at the same time. So they take this block set right here. Let me get you pictures.
You've been thinking about this for a while.
I commute 45 minutes to work every day. Live at the lake.
Yeah, you stitch it all together in your head, and you got it on paper.
And I got it on paper now.
Wow.
So you'll see there, we'll come here. You're gonna put it together a really nice video. I'll spend some time if you want.
Yeah, let's do it.
Okay, cool. So the students start off in the class drawing. So I'm a big believer that the students need to be able to understand drawings in order to make the parts. So we teach them a little bit of manual drafting, where we have them create the different views and the different drawings here. Then after that, we get them into measuring, because before they can even make a part, they got to be able to ensure that the part came out to the correct size. So we do a lot of different measuring activities with them using micrometers, calipers, and
Everything in these tool cribs.
Yes, everything in our VidMars. We have everything kitted up. Upon learning how to draw, they then start CNC machining, where you're going to see over here is our first CNC project. So here we have our first CNC project, where the students go through a detailed set of instructions on how to load the CNC. At the same time, they're watching videos on the control with the new Haas Gen 2 control.
Right, you loaded the control with the videos?
Correct, and also you'll see every setup sheet is actually located up on my control. So what I can do is in the media display, I can load media. So I'm able to go to my list programs, and with an M130 code, I can automatically bring up PDFs so the students can see how the setup works, making the educational process flawless.
So you took your project plan and you're now incorporating it into the actual control.
Correct.
All right.
So you'll notice, like in my user data, we're able to call up all the different setup sheets, and then now the students are able to learn how the setup works and learn about the different manufacturing process directly on the Haas control. So right here you can see this is the first operation setup sheet. We can zoom in, where it literally tells them how to zero out all the different work coordinate systems where the tool heights are located, and then a nice set tool list along with a setup of the actual, a picture of the actual setup.
And you did this on all the different machines?
Yeah, so now every operation...
Duplicated yourself.
Correct.
Okay.
So basically all 6 machines are the same. So what we have here is every operational, it'll pop up with a setup sheet before the student runs the part. They learn how to load our chick vices and then actually machine the parts and inspect them.
And in case there's any break in the process, you can create a video and just insert it into the control, right?
Correct.
If you're figuring things need to be changed or modified, you're able to go with the flow.
Correct, and stage 2 is actually going to be to have videos directly within my program.
Yeah.
So it's going to talk about face mailing and then go perform the actual process.
Yeah.
So I'm getting to that point. It just, again, 500 hours a summer. We're not quite there yet.
Yeah.
Very close.
Well, in your first couple weeks, man.
Exactly.
Give yourself a break.
Yeah. So, yeah, exactly. Just got married, right?
Yeah, that's right. Last week, right? Or last week or the week before? 3 weeks ago.
So you'll see for CNC Project 1, they take the first part through first operation where they're learning how the different pieces of information that are critical when you're setting up a CNC operation, like making sure that the workpiece's stick out height is above the milling vice's jaw so they don't accidentally mill the jaw and so forth. And then upon completion of that first operation, they have a little inspection where they have to go through and make sure their first op conforms to the engineering requirements.
They're using the inspection tools, or are they using
Yeah,
some?
so they're using calipers
Yeah.
mainly for the inspection on the mill.
Yeah.
So they have their own set of dial calipers. They go through and they measure it and basically make sure that the part matches the drawing.
So this part here is what the first group of students have already completed, or they're completed now.
Yeah, so this is the freshman mill part.
Yeah.
For our freshmen at Cal Poly are creating this part on the machine tool.
So they can read it here, they can see it there, and they can make it there.
Correct. And then they draw it in the CAD lab.
The
So
CAD lab,
it all
yeah.
starts with an engineering drawing.
Yeah.
So you'll see right here, once they finish the part, they actually have a first article inspection report they have to fill out on the part.
Oh.
So right here you'll see there's variables for like the thickness, where I actually make them go back and reference the engineering drawing, determine the target dimension off of the engineering drawing.
So they're filling this out
the
as they go.
limits. Correct. So they're filling out inspection sheets and learning about manufacturing through performing the different processes. Every project's got a manufacturing part routing explaining the process from start to finish. For example, cutting the stock to length on the saw, performing CNC mill operation 1, performing an inspection between the CNC operations, all the way down to washing and deburring the part at the end there. So after they read through the routings, they go through and then they have the same setup sheet they see on the control they can access in their manual so they can be prepared to set up that operation.
This is in the machine?
Correct.
The same.
So this exact PDF is in the machine. In fact, the entire lab manual can be in this machine. It's pretty impressive.
How easy was that getting these into the control?
It was literally if you can load a CNCG and M code program, you can load a PDF into the control. It's pretty remarkable what the engineers at Haas have done on this Generation 2 control. It blows my mind still, some of the options I'm finding.
It's good for teachers, right? I mean, this is
It's
something.
amazing for teachers. I would never recommend the older control over this control for if you're going to be buying a new machine to teach. Well, you
Okay.
can't even buy the old control anymore. But
Correct.
I would only get the new control. I wouldn't buy a used machine if you're teaching. You want to stay current with the technology.
Sure.
After they perform their first CNC mill project, they're comfortable with loading parts, inspecting parts, and understanding the basic machining processes. So we go on to a little bit more design, where we teach them allowance and clearance calculations in order to design parts that fit together. So you'll see their second mill project, they've got a top, a middle, and a bottom block. They basically are given an engineering drawing packet describing the sizes of the parts. For example, the top part has a certain basically slot thickness and depth with tolerances. They take those tolerances and they figure out the loosest and the tightest fit they want in between their mating parts, and then assign a size to the middle block that it mates up with. So they perform some simple calculations on the maximum and the least material conditions in order to come up with a nominal size and a tolerance for a part so they can fit them together. Now, this one's very interesting because I was challenged with the task in how do I make the students, allow the students to make mistakes on the CNC without costing hundreds of dollars in damage. Okay. So what I came up with is macro programs. Now I have macros unlocked on my machines, so I'm able to write macro programs. And what I do with that is I wrote a program that has the wrong answers and the right answers in it. And it asks the students, what size would you like to make this keyway or this slot, depending on what side they're doing. Based off their mathematical calculations, I have an answer that has the common wrong calculations, then I have the right answer, and then a couple of basically off-the-wall answers there. So they basically pick a number in the control on what size they'd like to make it through macro programming, and then it produces the slot or the keyway that to
So
that
for those
size.
that don't know what macro programming is, basically custom program that you're creating, right?
Correct. So it's a custom program I created. It allows me to ask the operator questions,
Yeah.
and based off the answer to that question, it's going to perform a different function. It'll pull one program or the other based off the questions. It's an amazing technology, the macros.
Which is something you can add to any Haas machine.
Yes,
It's built into it. You can.
Simple unlock code. You can call
Yeah.
your dealer and get that unlocked. Definitely. It's definitely worth the price. Now, the final project that we do in our class is a production project, where we're worried about the students. We want the students to know that time is equal to money out there. So our third and final project is the air motor project. It's actually been a Cal Poly tradition since 1988. And it actually ended up, this year's our 30th anniversary making the air motor, and now we're fully making them automated on the Haas machine. Just so happens to be Machining Time Saver's 30th anniversary as well.
That's
So
HFO Anaheim, who I work for.
HFO Anaheim.
Yeah.
So
Who supports you?
Haas dealer.
We're your local dealership.
Correct.
Right.
So I thought that was kind of an interesting fact. But we've been building this air motor for 30 years here at Cal Poly. Now we're fully automating the manufacturing process.
So you were making manually. These were manual mills about 3 months ago.
Right. These are manual mills, and we had a whole line of drill presses in here. So
Yeah.
we had a giant set of fixtures and drill jigs in order to manufacture this air motor, which we're able to reduce that with these Haas machines because we can multitask on these machines. We can drill, tap, face mill, and contour with the end mill. So
And the machines you had before were from the 50s.
correct, exactly.
But now this is the industry. This is where it's going.
We are now
Yeah.
neck and neck with industry right here
Right.
with our technology. So looking at this air motor project, you're going to see there's 6 unique parts that they're making. They actually machine 3 castings and then 3 parts out of raw stock. So the students actually go through and they set up the machine tools to make all 6 of these parts that you see right here. Now, how do they set up the machine tools, you ask? Well, in industry, we would look at a routing and a setup sheet. So what we have here, the students are given routings of all the steps and how to set them up. And throughout the process when they're manufacturing, they have to keep notes on any scrap or any scrap time that has occurred during the process. So they're able to come up with a final cost for the part.
Lean manufacturing.
Exactly. So they can figure out, oh, I just scrapped 3 castings, no big deal. It is a big deal.
It is a big deal. You shouldn't be scrapping hardly anything. Right?
Exactly.
Okay.
So we're trying to get across the point that time is money and scrap is money to these students. Now, looking through here, you'll see every step in the routing has an operation setup sheet. So the students will go through this op sheet, set up the saw or the lathe or the Haas mill in order to produce the part. So you can see right here, here's a little custom fixture I had to make in order to drill and ream a hole in this crank disc. And you can see here's another custom fixture we had to make in order to hold that crank disc for some contour.
So for those that maybe don't know what fixtures are, can you explain just in 60 seconds what a fixture is
So
in a CNC machine?
So a CNC machine, the most common work holding in a CNC machine is a vise, like you see right here.
Right.
In fact, this is a really nice vise. This is a Chick one-lock vise, and it allows you to expand the jaw more so than a standard vise out there. And everything we did in here was a soft jaw, where I actually cut a profile into the soft jaw to hold the workpiece.
Right.
So this is the most common work holding for a CNC mill. However, when you have something irregularly shaped, like you can see right here, this casting, you have to design a specific piece of work holding that holds just that part.
Right.
And that's what a fixture is.
Yes.
So you can see right here, this casting is held by this fixture on the datum targets. So this operation will actually face mill the top of this casting, or the bottom of this casting, to eliminate the draft so it could pull out of the mold. Then it comes through and drills the 2 mounting holes.
Okay.
In the past, before we had the Haas machine, this was 2 operations. We would do 1 facing operation on the manual mill, then we would take it over to a jig on a drill press, which a jig guides a tool, and drill the holes on the drill press.
So you created multiple fixtures for this next suite of parts.
Correct. So
Okay.
the air motor has a lot of dedicated fixtures that actually just go into the machine. So now the students get to see general purpose work holding and also dedicated work holding like a fixture. Right. And I'd also like to take a moment out to thank our sponsors. Sandvik is the #1 cutting tool manufacturer in the world, and they gave us a deep discount on the tooling for this lab, so we're able to afford the tooling, and every students are using the most state-of-the-art designed and engineered tooling out there.
Yeah.
Also, I'd like to thank Chick Work Holding for giving us a deep discount on the vices for this lab. These vices, we got half off on them, so it's an amazing discount. And #1, Haas Automation. We love your support. Thank you so much, Scott, for supporting us.
Yeah, I'm just a small component. HFO is a component, but
it's one big family, and
Yeah.
we're all here to support education. That's big. I've been working with Haas in education for over 12 years now, and they have supported me more than any other company out there. So that's what we're doing here.
All right, so what's next? Okay.
So what's next? So you'll see right over here, they're a little dirty. We had a fire drill right before we came into videotape, so normally we wouldn't have chips on the machine, but excuse that.
They're pretty clean.
Yeah,
you guys have a high standard.
That's
so.
dirty. A machine shop should be clean. So we have these 1956 LeBlanc Regal lathes, and this is the scariest thing to me, the lathes. They're old, they don't have emergency stops.
They're not enclosed.
They're not enclosed. That's the way the world's going, enclosed, automated.
Yeah.
We're training engineers here, we're not training machinists.
Right.
So my next goal would be to get 6 Haas tool room lathes in here and get rid of these old boat anchors.
Hey, Martin.
And there's our
Boat anchor.
You're wearing a Haas shirt. What's up with that? I wasn't expecting that, my friend.
Hey man, you gotta represent.
Yeah, you got to represent. So, Martin, how long you been? 30 years? 35 years? What was that?
34.
34 years. And so we're kind of handing over the reins to Trian, right?
Correct. So I met Martin at a H-Tech conference back in 2012. So
Yeah.
6 years ago in New York, I was working for Arizona State University.
Right.
And I was teaching CNC there. And Martin and I had a nice conversation, and here I am. So
Took me 2 years to talk him into coming.
I said no twice. So, but
I said no before I took this job. It's just, you know.
there you go. So
And you've been putting on a lot of conferences for many years here.
15 years.
15 years. So Martin is a host. Are you still hosting sometimes? The next one in summer for educators?
I'm handing it over to Trian.
we're
Okay.
we're going to tag team it together this summer. But yes,
We're gonna keep that going?
We train all of the high school educators
Yeah.
throughout the state of California here on the Central Coast.
So they come here and spend 2 days.
2
There's a
days.
couple keynotes.
2
There's
days.
breakout sessions.
Workshops on machining,
Yeah.
welding, drafting.
We have the architects come too, the drafting teachers.
Yeah.
It's a joint conference.
I think it's a great conference. I've come a couple years since you keep inviting me. Thank you.
It's all about promoting engineering education. That's what it's about.
Yeah, it's one of the cheapest, inexpensive, but good conferences. We get about 65 teachers.
And your daughter is super talented. She's working at a local industry. If people are searching on Instagram, it's what Machine Girl _. She posts a lot of machining videos.
Oh, she's endless.
She's
She's endless. Yeah, she's a certified welder and Haas operator.
yeah.
Yeah.
So what's next? Where are we gonna go?
So stage 3, after we
Okay.
get our Haas lathes in here,
Yeah.
we're gonna add a little bit more non-traditional manufacturing processes, or at least when I went to school, they were called non-traditional processes. We're gonna add some water jet, some laser cutting, and some fun activities that involve those different machine tools.
How many students do you think we're gonna?
Right
be
now,
doing
we're
this?
seeing about 700 engineering
700.
students come through this lab in
Okay.
3 quarters. This lab is highly impacted.
Mm-hmm.
It'd say is busy about 40 to 50 hours a week. We just happen to be at lunch break right now.
Yeah, I actually kind of just came in at a good time, didn't I?
Correct.
Because about an hour ago, this was all busy.
Correct.
This process that you put together, a lot of schools might find that a little daunting. How did you put this curriculum together?
So I've been machining for 20 years on Haas CNC machines, and I come from the aftermarket automotive industry, low
Yeah.
cash CNC, and we've been making parts for a long time. And I've kind of stepped back and looked back when I was 18, 19, first learning CNC, how daunting it was to figure out tooling and how everything's set up. So I just kind of go back to my roots, and I
Right.
bring elements back that I needed to learn from when I was in my early
If you had
20s.
this and more
Right,
of this,
that and that.
less of this,
And that's really how I put my curriculum together. I do go to all the conferences and look at the research papers on what's important in machining and what skill sets we need to be teaching. I talk to our industrial advisory board heavily in order to see which topics they want to see in our curriculum as well, because they're the ones that are hiring our students.
Right.
So that's where I gain my curriculum for, but I share it. So I present at the Haas H-Tech National Conferences every time I go.
You're the current president.
No, I'm actually now the past president.
You're past president.
I've been president twice.
Twice, okay.
Yes. So basically, I'm always willing to share all the material, but most of it was my proprietary material developed in my head over driving.
Would you recommend H-Tech Network?
Oh, yes.
Okay.
I mean,
Go to the conference.
It's a vital network.
Yeah.
So if you know you're going to be teaching CNC machining or some sort of manufacturing course, you need to get involved in this H-Tech network.
Okay.
It's a huge network. I mean, I have people all the time contacting me, asking me questions. I contact like Toby, ask him questions throughout the year. It's a great network.
You've got local high schools, Tim over at San Luis
Tim,
Obispo High School.
exactly.
You've got all kinds of high schools. It's like 1,500 schools right now, I think.
1,600.
1,600?
And, you know, you got the H-Tech in Northern Cal coming up at De Anza.
De Anza in October like 18th or 9th?
October 11th and 12th, I believe.
October 11th and 12th. And you've been there before, right?
Numerous times, yeah.
It's a phenomenal program. De Anza up in...
Deanne's got an amazing lab set up and program, so yes.
Yeah, we're going to be promoting that more and more right now. It's right around the corner. So go if you can, right?
Definitely. We'll be there.
You're going there?
Yep.
Okay. Well, we're going to finish up. Anything else you want to say about this program? I know I kind of just caught you off guard and I stuck a camera
No,
in your face.
I enjoy off-the-cuff videos, so hopefully you enjoyed seeing our lab setup. If you have any questions, you could always contact me at tgeorgeo@calpoly.edu. Again, that's tgeorgeo@calpoly.edu.
Thanks, everyone.
See ya.
Thank you.